Today I'm going to teach you a lesson on binary number conversion, and that is lesson 2.1.2 in our digital electronics curriculum. So let's get started. We're going to learn about binary number system, which is just a number system used by computers because they only know ones and zeros. And what I mean by ones and zeros is that they only have electrical pulses of yeses and nos, electricity or no electricity. And so instead of using the decimal number system, which is what we use every day, we use binary. Now, let's go back to second grade when we learned the decimal number system. So in the decimal number system, we have 10 different characters, 0 through 10. It seems like we have 9 characters, but don't forget that the 0 is also included, so that is actually 10 characters. Now, when we count, we actually count using only those 10 characters. Well, what happens if we have to count to a number higher than 10? We just use a combination of those same characters. For example, if I have the number 349, I have the same characters that if I would say the number 934. So the difference is just the location of where the number is placed. It is not that I'm using a different character. As you can see, it's the same 3 characters. It's just that the location is in a different place. Now, how do I know what place value, what weight the place value has? Well, that's just it's just the location. So for example, if I have, in this case, the decimal number system has 10 different characters. 10 to the 0 is 1. 10 to the 1 is 10. 10 to the 2 is 100. 10 cubed is 1,000. And it goes on to infinity as high as you want to count. So if I put a number in my hundreds place, like the 3, that means 3 100s. That means 4 10s and 9 1s, as opposed to having 9 3 4, like in the previous example. The 9 now means that it's in the hundreds place, the 3 is in the tens place, and the 4 in the ones. So the difference, again, is that the number means the same thing, but now it's in a different location, or the place value. And that's because we have 10 symbols, and the exponent tells you the place, or the place value quantity. Now, let's learn about binary. In binary, we only have 2 characters, 0 and 1. So when we have numbers like 0 1 0 or 1 0 0, those we use the same characters again, just like we do in decimal, but the location has a different meaning. In base 10, we have 10 characters to the 0 power, to the 1, to the 2, to the 3. In binary, we only have 2 characters. 2 to the 0 gives me my ones place, because any number to the 0 power is 1. 2 to the 1 is 2. 2 squared, or to the second power, is 4. 2 cubed is 8. 2 to the 4th is 16. And it goes on to infinity, just like in base 10. So again, the place value, just like in base 10, is determined by the number of characters to the exponent. Same thing here. So just like we've grown up all our lives knowing that this is the ones place, the tens place, hundreds, 1,000, in binary, this is the ones, the twos, the fours, the eights place. So if I have a 1 here and a 1 here, like in this earlier example, that means that I have 4, 1 4, and 1 1, which is equal to what we know as 5. If I have this number like this, that means that I have 1 4 and 0 2s and 0 1s, so that's just the same as saying 4. Other examples are like the number 20, for example. The number 20, I would need 116 and 1 4 and 0 8s, 0 2s, and 0 1s. So 16 plus 4 is 20. Another example is the number 3. How would I say the number 3? I would need a 2 and a 1 to say 3. A simpler one, not a simpler one, but one that I think is kind of cool, is number 7. Because for that, I need a 4 plus 2 is 6 plus 1 is 7. So this equals to 7, which is 1 less than 8. So 8, I would say it like this. So it's 1 8 and no 4s, no 2s, and no 1s. So it's kind of like over here, if I count 99 means 9 10s and 9 1s. Well, what's 99 plus 1? Well, these become 0 and this becomes 1, right? Here's like a similar number to 99. We have the highest number you can reach with the number of characters we have, and they all get reset and become 1. So this becomes 8. One cool thing that I like to tell my students is this. What is this number right here? That, if you see, is 1, 2, and 0, 1, so that's just 2. So 1, 0, if I write this number on the board without any information, it can be 10 in base 10, or it can be 2 in base 2. There's a little saying that says this. There are these many types of people. Those who understand binary and those who don't. Do you get it? There are 10 types of people. Hey, you're missing 2. I mean, you only have 2, you're missing 8. Well, no, that's just because you don't understand binary. Because if you understood binary, that just says 2. Thank you. That's it.